So we're going to look at linear approximations. And so let's take a look at the idea first. And the idea is pretty simple. You know, there's some formulas involved, but really understanding it is not very complicated. Let's say, for example, we have this function. This is square root of x. And, you know, the idea is that, for example, we know, you know, for example, if I plug in 1 inside of the function, that's easy to calculate. That's the value 1 right there. So when x is equal to 1, y is equal to 1. If you plug in 4, for example, you would get 2, right? So if you plug in when x is equal to 4, y is equal to 2. And if you plug in 9 into the same function, you would get 3. Okay, so that's easy. Those are all easy to find. You know, you don't need a calculator or anything. But what about, for example, what about if you want to know what is the square root of, let's say, 5? Well, this one, to approximate it, you would need a calculator. But take a look at this. Notice that at the point, so 5, x is equal to 5 is pretty close to, which is this one. This is the one that we want. It's pretty close to 4. Notice how if I draw a tangent line right here at 4, that tangent line at 5 is really close to my the value of square root of x. So very, very, very close. But, you know, a tangent line, you know, plugging in a number into a line is very, very easy. So the basic idea is that if we're looking for example, square root of 5, which is difficult to find without a calculator, of course, what we do is we find the tangent line at a point that's close, but not difficult. So here, for example, we would choose 4 because I know the square root of 4 is 2. You find the tangent line and you plug 5 into that tangent line because that would be easy. Okay, so let's do that. Okay, so what I'm going to do is I'm going to write down my steps over here. And so we said that our first step is going to find the equation of the tangent line at, I'm going to call it the easy point. And then in parentheses, I'm going to put this easy point is going to be near the point we are looking for. Okay, so in this example, that point is x equals to 4. So we're looking for the square root of 5 right here. We want to estimate that. And so we're going to find the equation of the tangent line at our easy point, which is x equals to 4. So if x is equal to 4, then the first thing we do is we want to find the slope. So to find the slope, we need to find the derivative of our function. So the derivative of square root of x is 1 over 2 root x. Okay, and then the slope is equal to 1 over 2 square root of, we plug in our number 4. Okay, so this is going to be 1/4. Okay, so that's our slope. And then the second part is we're going to find the y-intercept. So the y-intercept, we write down that y is equal to mx plus b. We plug in our newfound slope, which is 1/4. we plug in our x value, which we know is equal to 4, and our y value is simply the value of the function at 4. So if I plug in 4 into the function, I would get 2. So y is going to equal to 2. Okay, so if I plug all that in and I solve for b, I would get that b is equal to 1. Okay, well that was easy, right? So now what we do is we will write down the equation of the line. So my line is equal to my that purple line that I just drew right here. The equation of that is y equals to 1/4 x plus 1. Okay, so another name for this is also called the linearization of f of x equals to square root of x at x equals 4. Fancy name for saying the equation of the tangent line at 4. Okay, now to continue here my steps, then my second step, once I found the tangent line, is you're going to plug in we're going to call it the hard point. Now the hard point is the point we are looking for. So in this case, what we're looking for is, in this case, we're looking for when x is equal to 5. And that's from up here. Remember we said that we were looking for the square root of 5. And so what we do is we plug in the hard point x equals to 5 into the tangent line. Okay, so what we say then is, so here's step 2. So what we say is that f of 5 is approximately equal to 1/4 times 5 plus 1. Okay, so this is 5/4 plus 1. So why don't we just turn that into decimals? 5/4 is 1.25 plus 1, which is 2.25. And so that's approximately what it is. Okay, so now let's talk a little bit about, well, how far off are we? Let's find the error and the percent error. Okay, so the error is simply the absolute value of the approximate minus the actual. And so our approximation was 2.25, and then minus the actual. This you can get by plugging in square root of 5 into your calculator. So if you do that, you would get 2.2361. Let's say I round it off to 4 decimal places. And this is equal to 0.0139. So that's how far off you are. I mean, that's pretty close, I think. And then the percent error is equal to the error that you found earlier. It's this one right here, over the actual, and then times 100 to turn it into a percent. And so if you do that, you would get 0.623%. So that's the percentage that you're off of the actual value. So, you know, this is pretty good stuff right there.